Okay, so today we are coming to learn about pointers, how to reference a pointer, structure and then arrays. A pointer is simply a variable that stores the location where the data for the variable is being stored. When you store something, the variable is being kept in a memory address. Yes, the address have a there's an address attached to it. Everything is stored in the variable as an address in your memory attached to it. So the pointers are used to get these memory addresses. Yes, so the pointer only stores where the memory address is being stored. Is it just gives you output the memory address for you to view. So how do you um, declare the pointer? How do you work with pointers? With pointers, we use asterisks in it. So, so let's go to our code here. So if you in the data, with the to create the pointer, you need your data type with the asterisk on top, and then the name of the pointer. Yes. So that's all you use to point to where it is the value is being stored, and then the variable which you are trying to find its location must have an ampersand preceding it as a prefix. So let's say we created a variable to store data as the int with the age that I have, and then we store it as 21. Yes, this variable actually has a memory address inside our memory in this inside our machine. So we want to find our memory address. So what to do is you use the same data type which you use for that variable, which is the int. Then you bring the asterisk. Then the name of the pointer will be name it age pointer. Age pointer. So should be equal to then an ampersand, then the age, then you close it with a semicolon. Every line of code that you write, you have to use the terminator, the semicolon, to show that this is where it starts and where this is where it begins. So you have to use it always, else you to do where you just getting errors. So this is where the declaration for the um, age ends. This where the pointer also ends. It starts on the fifth line, ends here. Okay, so that's what is the terminator for. So right now, how are you going to get um the address? So with the address, you bring your C out, which you've been doing normally. Then you bring the asterisk, you do H Then you bring the H pointer, that's the name of your pointer, to point to the address where your 21 is being stored. And you close it, or if you like, you can still add the end line. The end line, just if there's any output after the that one, it will come to, it will output it on the next line. If you have to output anything, the end line will just make sure the next output comes on the next line. You save it and then you run it to see what it gives us. Okay. I think there's an issue here. Um, let me see. Okay, yeah, I think there's it. So this is the address where our 21 is being stored in our system. This is where our 21 is being stored in our computer's system. Yeah, in this address. So now we want to dereference it. Dereferencing is just finding where your finding the data that is being stored at that location. So to dereference it, that's when you rather bring the asterisk before the H pointer. Not sorry for that. Anyway. So you rather bring the asterisk before the H pointer in order to dereference it or show the value that is inside it. So you bring your asterisk, save, then you print, you output, then you get 21. So at this pointer, at this address, we have the value 21 being stored at the address. Let me just type another line. See out, then H pointer, then end S. So it means at this address, this number is being stored. This value is being stored over there. So that's what it means. The address actually in hexadecimal format. So that's about pointers and the dereferencing a pointer. So let's go to arrays. Arrays are variables that are being used to store multiple data. Yes, we use arrays to store multiple data in our programming language, in our coding. Yes. So also to declare the array, you need your data type, the name of the array, and then the size. The size should come in the square brackets. There you should write up the size in the square bracket, then equal to, then you enclose your value. If you input 10 as the size, and then you go and input the less than mm, less than the number or greater than the number. If it is less than, at times it will auto generate values for you, and depending on how you write code. So to do the array, you need your data type, which is the int. And then let's say you want to store people's ages, so we have age as the array name. Then no, sorry, square bracket rather. So the number of people's age you want to store is just 5 people. So we input 5. You can choose any number of your choice. Then you enclose those 5 people's data in the curly braces. Open and close curly braces. So maybe the first person is 21, comma. Next person is 23, comma. Next person is 56, comma. Next person is 45, 24. So we are left with maybe 23, another 23-year-old guy. Let me just 26. So, and then you close it to the semicolon. That shows the end of declaring your array. So the 5 here corresponds to the number of data here. We have one, two, three, 4, and then 5. Okay. So if you input 5 here, the data have to be 5. But in the array, when you want to access the data in it, we don't use, okay, it is not being count, it doesn't count from 1, it counts from 0. So the first digit here is index 0, the second one is 1, the third 2, fourth 3, and then the fifth 4. Okay. So if you want to maybe actually output the value of the array, we do cout less than as usual. You type h. So which value in the h do you want to access? So I want to access the first one, which is index 0. It is not indexed 1. It is being counted. The data in the array are being indexed from 0. So cout 0. Yeah. Save the code and then you run it. It's going to output 21 for you because 21 is the first number, and the first number is indexed as 0, not a 1. So if you want the second one, you put 1, which gives you 23. The output here 23, and 23 is the number here, is a number in the second position. So that's all for that right now. So we'll do structures is a structure. Um, what is actually a structure? Structures are being used to also store data or store member data of people. Yes. So maybe you want to store the data of maybe a person or someone or a lot different people. You can use a structure also to store it, and then you output this out the structure also. Mm. So to write the structure, you have to bring the keyword struct. So inside your main function, your int main function, You bring struct. That's the keyword that I used to start. Then what do you want to store? Record of maybe some um, maybe lec- maybe a lecture. Yes, lectures. Then you bring your curly braces over here. Or maybe let's say lecture. Yeah. Do so what do you want to store about that person? The lecture. If you want to access, if you want to, you just declare the variable. Maybe you want to store the age. So you type int age. There's an error somewhere. Okay, let's just terminate. Yeah. So int age um, is equal to 39 or something. And then you come down, maybe you want to store the person's name. So use string name. Yeah, so use something like alphabet. Sorry. So now what I don't know how to say it. You have to give a specific name or something to the structure I'll give you. So which lecturers records are you picking? You're picking maybe probably Mark, the lecturer called Mark. So you end it as Mark. Yes. So right now, how will you access the data being stored in this structure? Okay. So for you to access this data, you bring the variable name and then the member name is actually Mark, lecturer Mark. So maybe mm, you type something like Hubert. Sorry, there's no Hubert here. Mark dot the H. Yes, so see out. Sorry, see out. Here. Okay, let me change. So you get 39 actually from here. So this extract the name for the structure something. So you want to access the value here is mark dot h. Do you want to access the name of the lecture you use? Name mark dot name to compile and then gives you the output Hubert. So that's the name of the lecture we are looking for. So right now that's how structures work in C++. Thank you very much.